Connect. So today we have Pallavi and Rohit with us. So they will be helping us to understand the term micro front end. Also, they will be helping us to understand how to bundle the micro front end in an optimized manner. Uh, and also they will be presenting us some demo. So without much delay, I'm over to you, Rohit and Pallavi.
All right. Thanks, Sridhar. I think he's already given a bit introduction on the topic. So yeah, I mean, like the topic is effective web tagging for micro frontends. Before I start, if you have any questions, I think we'll take them at the end. So feel free to just put them up on the Zoom chat. We'll be taking them in the end. So I think just a bit of introduction about me. My name is Pallavi, and I'm a senior developer with ThoughtWorks. Worked with different sorts of architecture like microservices, also dabbing my hands on micro frontend with my current one. And yeah, I mean, like that's it. Over to you, Rohit.
Hello, I'm Rohit. I am a senior UI developer at ThoughtWorks. I've been working here for 2.5 years. I primarily work with front-end technologies, mostly React, JavaScript, etc. And that's it. I think we can get started.
All right. Okay, everybody can see the first slide because I just started continuing. Perfect. So this is just a short on what we'll be talking about. I think we'll mainly touch base on micro frontends. Just do some brush up of basics on what they are, how they look like, and what would a standard cut on why do we even need them. And after that, I think we'll deep dive more onto the web packing part of it. And more interestingly, how would you do, and why would you even need an optimization when it comes to micro frontend? Okay, next one. So right, so the first section we'll just probably go through what micro frontends are. And I think this is like a textbook definition that you can say for the micro frontends. So I'll just read it out first. It's an architectural style where independently deliverable front-end applications are composed into a greater whole. Uh, Now, I mean, like just to go into more details, how I consider it's nothing but a pattern. So I mean, like if you have already worked with microservice architecture, I think this would seem quite similar to you. So it's basically when you have like a big front end monolith, you sort of divide those into smaller, simpler chunks, which can be actually individually, they can be developed, tested autonomously. And on the front end side, your customer will, there will be no change for the customer. But architecturally wise, I mean, like it has its own benefits and everything. And you basically divide a big whole application into smaller parts. Um, Moving on. So we have a small example for you. I think everybody must be familiar with the classic Flipkart website. So for instance, suppose you have this giant e-commerce website, and you want to just take a first shot at how, if I want to split it into micro frontends, how would that cut be look like? So you might have different parts of it. So looking at it, like the first cut can be, you can move out the search into a small micro frontend. You can move this login part out. You can move this cart button, like the whole checkout thing, out. You can even have sort of this deals of the day part out in this category. So I mean, like we've just taken like a first step. Might not be the best cut. I mean, like it depends on your organization and also how your application is. But ideally, you would wanna do the split in such a way that they're not really dependent on each other, and they serve a purpose of its own, right? So how I consider is like, if you're assembling a PC chassis, you have these different slots. So this looks like plug and playable, and micro frontend is sort of similar to that concept. That you take a micro frontend, you develop it individually, and then you just plug it into the main website. Um, all right. So I think we've already covered some of the benefits of what you get out of it. One of the I think biggest one that I would say is incremental upgrades. So I think a classic example of this would be, say you have a big monolith micro front end, which was developed maybe quite a bit, like quite a in olden times, and you think that you realize that maybe I should move my tech stack, or maybe I'm not able to achieve what I wanted to with the given tech stack. So in order to modernize that, you either can do it like big bang, like all of it, you start developing it, and but I mean like that would take like a bigger cycle. The other part that you can do is you can go the micro front end way. So you can actually identify different sections of your website that you want to modernize first. So like we saw in the previous example, you can take this deals part and you can say, let me take this small bit and let me convert it into a micro front end, remove the old one and plug it the new one. So in this way, what you can do is you're actually able to develop it separately, incrementally, and you're actually able to see the advantages of it like over the period of time. So um, that's one. The other is the whole ideology of micro frontends is it has to be small, it has to be individual, it has to be autonomous. So you ultimately end up with simple decoupled code bases and uh, autonomy in the sense that you can have different teams working on it simultaneously at the same time, and since they have their own concern that they address, I think like I think this one then automatically checks out. The deployment also, I mean like your like in the previous example, if you're working on this and search at the same time, I mean like the releases can be independent for both of them, it doesn't have to be dependent as such. So there's that comes, I mean like again, like I think like microservices, there are some caveats to it. But yeah, I mean like we'll cover that and see what they are in a little later. But yeah, I mean like it's not a pill for all diseases, I would say. I mean like you will have to take a call if it actually fits your use case and what you want to achieve. All right. uh, Moving on, the next is webpack. Over to you, Rohit.
So we thought we'd just touch on Webpack just in case someone is not aware of what it is, because we will be deep diving into Webpack configuration quite a lot in the coming hour. So Webpack is, can we go to the next slide? Yes. So the official definition kind of is that Webpack is a static module bundler. So what Webpack basically does is it takes your application code, your React code, your Angular code, or your native JavaScript code, and it bundles it all together. So you have all of your codes, and you usually have modules, your functions, which have exported and then imported in other files. You have your CSS, you have your images, and you have many times multiple functions being used in multiple places. Webpack kind of creates a dependency graph of your entire project, and it creates one optimized bundle, which would then be what you would serve to the browsers for them to load your application. Majority of JavaScript frameworks today, including React and Angular, in their default setup, they come with Webpack. So any kind of optimization that you're trying to do, any kind of performance enhancement, it becomes very important to understand Webpack at its core. Uh, Moving on.
All right. Now that we have covered the basic theory, let's try to see an example that we have prepared here, and I think we will be building up on top of it. Yeah, I mean, like we have created sort of a small micro frontend example for you. So let me go. Yeah. So doesn't look the best of the things, but I mean, like it gets the point delivered. So here, if you see, let me do an inspect. Okay, perfect. So you can see here in the example, like this is the whole container. So you can consider as your main website. And we have like two micro frontends that we have injected here. So one you can consider as the login, as you can see, like the whole chunk block, it's like div hash login. And this whole, okay, yeah, so this part is search. So these are two micro frontends that we've injected into the main website. And if we were to go look at a code of the container, it's very basic HTML. I mean, like it just contains two div, one for login, one for search. But if you closely notice it, there's no code inside it. Why? Because we are injecting that via micro frontend. So these are the two micro frontends that are separate. We'll go into see the code for that later on. I think for now, just like if you see here on the page load, there are some certain functions which are called which we have called here search bootstrap, and we're passing the ID for this particular element, and this login bootstrap for which we are passing the ID for the login element of the main container. Now, these two functions, how does the even main container know about it? I think the answer to that is quite simple. The micro frontends are including those functions for the main container to call. Okay, so ignore this for now. I think this is just the micro frontends that are being injected via a script tag here. So I think in the whole micro frontends paradigm in general, the way you inject your micro frontend into the main container, I think there are certain ways that you can go forward with. We have gone forward with the runtime way, not the build time. So I mean, like I can independently make the changes to my like the separate micro frontends, and that at runtime, whenever a user actually loads this main page, they'll actually get these micro frontends in like the build file at the runtime. So this is the runtime way of injecting a micro frontend. There's also a build time that I think we'll share some references for you. If you're interested, you can have a look on how that works. Okay, moving on, let's try to see what is there in the code. So in order to make it like a micro front end, we have made a bit of changes. So I don't know if how many of you must have observed, but if you consider a standard CRA, so these applications, the login and the search were created with the CRA template that you have. And if you were to go and see, um, let's try to just compare. So what changes have we done? So if you see a standard index.js file, right? This is the one that you get when you create your app freshly with the npx create react.js command. Npx like create CRA, the command that you have. And if you were to see, like let's see the difference of how we or what we have modified. So I'll just take both of these and let's do a quick compare. All right. So ideally, by default, your React application, when it renders the whole application onto something called root. So that's the ID that it knows that, I have to mount my whole application on. In our case, it's a micro front end. So we don't want to mount it on the root because the main container for it is supposed to exist outside. So like I told you, right, there were some certain functions which the container was calling. This is where those functions are being declared. So you can see here, it's window.login bootstrap, and we are passing it a function. The element is quite similar, apart from the fact that the ID is being passed from outside. So this way, the container actually has a sort of control on the micro front end that, this is where this is the ID for it, and I have to call and put it here and inject it here. So this is ultimately the change that we have done. And if you see here, this line actually now makes a bit of sense, that my main container has some IDs, and it's actually saying that, let's call the search bootstrap, let's bootstrap it, and let's bootstrap and put it inside the div ID, which is the search. So this way, we are able to get this and mount it on the div ID login, which belong to the main container. And this is your whole app. So if you see, this is your whole React application, and it's got like the class app. All right. Couple, I think this covered. All right. So next thing is this script. So if you consider Okay. Am I still online? Can you hear me?
Yes, yes.
Okay. No, sorry, I this hand. All right. So here, if you see, React by default does some smart things, which is cache busting, tree shaking, and all of those things, which means your build output is actually chunked. Now, if it's chunked, I mean, like the problem that we have got here is we'll not be able to inject it. We want it to be fixed. We want the name to be fixed. So we have disabled the chunking in our configuration. So if you were to go and see the build folder, uh, like there's just one main.js file. So we've disabled the chunking for the sake of it, and we've directly injected it here. Uh, okay, this done. Um, Now I think let's try to do some analysis. So what I'm gonna do right now is the terminal is still visible, right?
Yes.
Okay, perfect. So what we're gonna do is let's create a fresh build and we're gonna analyze it and see what exactly is inside it. Um, okay, my machine is low in battery and speed. All right, so this one went fast. So login, the bill got generated. And if you notice, like if you make a note of the size, the main.js is approximately 100 KB, give or take. And that's after gzip, right? What that thing. And for the search, if you see here, it's around 122. So both of them almost 100. We'll try to, that's what we're going to optimize in the further talk. And I'm just gonna see, let's just try to see what exactly is in those KBs. Okay. All right. Okay, so this is for search and this is for this. All right, so let's see. So this is your whole build, and if you see what is exactly inside it, you can see there's React DOM taking approximately 28% of the big chunk. You've got Material UI for the styling that we've used, which is again taking approximately like 21%. We've got Algolia search. I think that's what we're using for the whole search feature. You've got like React modal, another 4.5%. So just notice like React DOM, 28%. And if you see the other build folder, which was for the login, React DOM again is taking 35%. Material UI again, 27%, which was already taking its fair share here also. So, I mean, like, we definitely like this whole, like even the React, right? The main React library also getting loaded. So if you see this load time, I mean, Micro Frontend isn't really giving me any advantage. It's actually causing a lot of loads. So isn't that gonna make my website slow? The answer is maybe. And we're gonna solve this problem in the later slides, right?
So it may not be visible with these just two micro frontends, but as you have 5 or 6 micro frontends, that 116 KB of React DOM being added for each micro frontend, that material UI being added, that will really add up to increase the total load time of your page. And when it comes to front end, you want to save every kilobyte that you can save so that your website loads really fast.
Yes. All right, so that was for the beginning demo. Rohit, you want to share the slide, or I can also continue with the way it's going?
Yeah, I can share.
Perfect.
Just a second. Can you see the slides?
Yes.
Okay. So these are some common pitfalls. The ones in bold, they are in bold because these are the ones we are going to focus on today. The major one that you are going to have these common libraries which are going to be present in all of your micro frontends, and that's a catch because you want your micro frontend, especially in this runtime setup, to be completely independent so that they don't depend on others. At the same time, you also want to optimize every single byte that you download. Now, that duplication leads to increased download size, like we covered. The other pitfalls are maintenance and consistency. You have multiple projects to maintain. You have the communication that must happen between the teams that are running these different projects. One major thing is getting the splits wrong. It is very important that you kind of split your application into the correct independent features that each become a micro frontend so that you don't have a lot of overlap. Another issue could be because all of these micro frontends are running in the same browser, debugging could become difficult, and communication between micro frontends, like not just the teams, but the micro frontends, because together they form one application in the UI. You need to take care of how these different parts of the application are going to communicate. Now, the ones below have the communication between micro frontends and other problems already have known solutions that you can just Google and find out about. The first two is something that we ran into when we were working on a micro frontend setup. Uh, uh, and this talk is about how we solved that problem. So going on ahead to the next slide. Okay, sorry, I forgot that I was sharing the screen. Yes. So what does this remind you of anything? Is this something that you have seen before? Does this remind you of any childhood frustrations of dealing with Windows machines? Uh, I remember these errors coming out a lot, like installing a new application and then some DLL file is missing. So we'll get to why that is of context here because in the next slide. So basically what DLL is, like I said, these were things that these were errors that you primarily used to see in Windows operating systems. That is because DLL was a concept introduced by Microsoft for the Windows operating systems. It stands for Dynamic Link Library. It is essentially Microsoft's way of sharing functionality between different programs that run on their operating system. Just like you have in front end, you also have this same problem in operating systems where multiple softwares would need same functionality. And so that they don't have to build it over again, operating systems would generally provide some of those features via, in case of Windows, via DLL files. In case of Windows, majority of the operating system functionality was actually provided by DLL. So this concept is of relevance here because there is something called as the webpack DLL plugin. It's basically the same concept of DLL in Windows being adopted by webpack to solve the problem that we are discussing, that how do you take these multiple micro frontends and share the common dependencies and the common code. Now, it's not really specific to micro frontends. Whenever you have multiple of these JavaScript bundles being loaded on the same window, Webpack DLL plugin can help you share the dependencies between them while keeping them independent so that the download time together of all of it combined is reduced by quite a lot. Okay, so now let's look at how we actually achieve this. I'm going to stop screen sharing and share some code. We have the exact same setup that Pallavi was just sharing here open on my laptop as well. And I am also going to share, just a second.
Yes. Spoiler, Rohit.
Sorry?
You just gave a spoiler.
Ah, sorry. The slide changed accidentally. Anyways, yes. we have these different file sizes, right? 326 kilobytes is, okay, this is wrong. Yeah, 223 kilobytes is what our application at the moment is totaling to, majority of which is React being repeated in both the places and other dependencies being repeated in both the places. Can you all see the code window that I shared?
Yeah.
Yep. Okay. So now let's look at how we would solve this. Like we said, we'll be using the webpack DLL plugin. We have the setup ready because this talk is a really short time and we wanted to cover most of it. So going and opening the webpack configuration that we have for this project. This is a new project that we created called Common, which we will be using to bundle together all of our common dependencies. In our case, that's React, React modal, material UI, and style components. So let's start with the package JSON maybe. Just a second. Okay, so this is what package JSON looks like right now. This is the basic template of this application, and basically these are all the tools we need for creating a basic webpack bundle. The webpack configuration looks like this. So the idea is that we are going to add all of the common dependencies to this package.json file to this project so that we can bundle them separately. Just give me a moment. I have the improved kind of already done code in a separate commit. Okay. Yes. So I have quickly added React, React Dev, React DOM, React Modal, style components. And these were all the common things that we were seeing in the analysis of the two bundles. Now we go to Webpack and we are basically creating a new output, which is going to be called Commons. The name here indicates just the name of the current package of the current project, which is Commons. And we are going to create a commons.js file, which is going to include, if you see, these commons. And I'm going to click on here and we have all of these present over here. We have a separate file called commons.js. There is no need to have a separate file. You can also put all of these in the webpack config directly. And these are being bundled over here. And then we have this, which is the interesting part, which says that use the webpack DLL plugin and create a manifest.json file. Now a manifest.json file, we will open it in just a moment. This file, once created, actually contains all the details of everything that is coming pre-bundled with this application or with this common.js bundle. If you look at build, you have the manifest.json file. Let me prettify it. I'm at the end somehow. Let's go to the top. Yes. You can see this file, it's usually a large file. Don't worry, this is not downloaded in the front end, so it doesn't really matter. But you see React index.js, this is all the information that what all is present in this commons.js bundle. Now what we are going to do is we are going to go to our micro frontends. First, we are going to go to our container application and simply include this. It's ready here. I'm just going to uncomment. Now we are including the commons.js bundle. Now React, React DOM, and all the common dependencies are going to be downloaded from here. But we need to tell these two micro frontends that, okay, don't worry about React, don't worry about material UI. Those are going to be already present on the page, while you also want them present here locally so that it helps with your local development and with syntax highlighting, etc., etc. So we go to search, we go to configuration and webpack configuration, and we add this chunk here, which is the second part of the DLL plugin, which is called the DLL reference plugin, which basically says, okay, take this manifest file. I'll just click here and show you where the manifest file is coming from. It's just present locally. This is the same file that was bundled in the common application. It basically says, take this file and don't include everything that this file says in the current bundle because that's already going to be there. And we do the same thing now for login, the other micro frontend that we have. I'm going to uncomment this. And now we have, and that is it actually, that's it. You just need to tell Webpack that these dependencies are already present on the page and we are basically done. Now, I don't know if there is something I missed out on. Let's just run. Let's just build this again and give it a shot. Okay, let's build all of this again. Let me stop the existing running application. Uh, if everything goes right, we will see that the bundle sizes of login and search are going to reduce drastically. Let's build them together to save time. Now, if you take a look at this bundle, it is 2 kilobytes. It was 100 kilobytes earlier. And if you take a look at the search bundle, it's 22 kilobytes, which was again 120 kilobytes or something earlier. But that's not it, right? Because we have added another bundle. So we need to take a look at that size as well. Let's build this project. Okay, this is significant. This is 166 kilobytes. Let's add them up. Okay, search was, I forgot, 22.97. This was something around 2.5, a little less, doesn't matter. And this was 166. And we have a total of 191, and we just saved 14%. Now 14% is okay, but come on, it's not that impressive. Uh, just to cover up everything, we have the container app, and we have included the commons bundle here. Both these bundles don't contain the common dependencies anymore. They are fetching them from here. But if you see the difference, this was reduced by 100. This was reduced by roughly 100. If these are being reduced by 100 each, where is this 166 coming from? Isn't that a lot? Shouldn't this reflect the same change of around 100 kilobytes that got reduced from each of these? And shouldn't this value be less? For that, we have to remember something in Webpack known as tree shaking. So basically, tree shaking is the idea that when you are including something like material UI, which has a lot of components, you don't always need the entire library. You need specific components from there. For example, if you're just using a button from material UI, you don't need everything else. So what Webpack does is Webpack optimizes everything to make sure only the files that you need are going to be included. But that information of which components of from material UI you actually need is something that this common application does not have. All we are saying here is that include material UI core, but we don't actually need the entirety of material UI core. We need just specific components. And that is where this is not yet a significant difference. We can actually optimize this further. Again, to save time, I have some code here ready that I'm just going to copy paste. So this is the list of material UI components that we are using in those two applications. And we are going to say, we only need this. We don't need entire material UI. Dot, dot, one more dot. Something is missing. Yes, my laptop is just slow maybe. Okay, now let's run the builds again. Let's run all the builds again. Now the common build is just 106 kilobytes. This may impact the other builds a little bit because they may be using some material UI bit that we have not included in commons. Webpack and the dealer plugin are very smart here. If you include a component from material UI that you are, in this case, not including in the commons build, Webpack will make sure that only that component is loaded in that bundle. So the builds are done. These are the sizes that we have now, 2.92. This has surprisingly increased, maybe just a little bit of variance with gzip. 2.92 and 23.17. This is now 23.17. This is 2.9. This was earlier as well, 2.9 actually. I'll change this. And this is where the significant difference is. This is now 106 kilobytes, 0.46. Now, if you see, the total comes down to only 132 kilobytes. We have reduced 40% of the download time for the application. Just to make sure that the application is still running, let's just open it. Okay, sorry, let me run this again because this build was in progress. You have to make sure that this build happens before that, otherwise it will not file in the manifest file. Okay, and now I will open, here's hoping that it works. Close 5000 again, and it works.
Rohit, we have a question that I think we can also show it right away. That how are the individual micro frontends will work if the dependencies are all pulled out?
Okay. Yeah. You want to try answering that, or should I go ahead?
Yes. I mean, like I added a comment there. I was thinking we can also show it. So for everybody, I think so for the commons, we also included that into the public HTML file for each micro frontend, so that the standalone micro frontend is also able to work just fine. And given in its build folder, the dependencies are no longer there. So I think Rohit is just showing, yes, that's the commented code.
If you want to basically do the development of search independently without having anything else, you will have to include the commons file there as well, because your default build does not include it anymore. But you could theoretically, and actually practically also, you could also make this dependent on the type of build. You could only use webpack DLL for a prod build and skip it for a development build. You could, I will not go ahead and implement that right now, but I will just show. So in generally in your webpack configuration, there will be this variable called is environment development. This basically is that what to do if it's development, what to do if it's production. You could skip webpack DLL plugin for your local environments and only do it for production. That is also one way you can go about it. And
and also, like I think with this script being added, I think it creates a dependency that the server on the common repo should exist. I mean, like you can also, if this you choose to do that with webpack, and I think we also tried one of the ways where we had the commons injected, like we had created a library for the whole thing, and we were copying that JS file into the build folder, I think with one of the webpack plugins. I forgot its name.
Copy plugin, the webpack.
Copy plugin, yes.
So we had exposed the commons as an npm package so that so I think the problem that Pallavi is trying to answer is or explain is, how do you share the manifest.json file that we have included here? That each, so search is going to need to point to that manifest.json in build time. Search manifest. How do you basically share this? Now, multiple approaches. What we used is we used to commit this file and just expose it as an npm package, and then the path here would be something like node modules, commons, DLL manifest.
Yes.
Another way is you could have this entire setup as a mono repo with a multi-package setup, and then everything is available locally, similar to what we have here. It's not a mono repo, but everything is available in the same directory. So we can just do a // commons commons.js. Okay. Another thing that you just saw is that this was white earlier and this is now blue. So interesting thing that some React packages don't work very well when there are two instances of them, because they tend to overlap with each other. And React also had this problem earlier of running two different React in the same browser window. This actually also solves that, because now there is just one material UI, so the theming is working more correctly. Earlier setup, there were two material UIs trying to style and store the style in the head tags separately, and they could conflict each other, leading to some weird bugs. But that problem is also solved in this setup. Actually, I also noticed this just now. Okay, now let's go back to the slides.
Yeah, I think we already covered the stats. So these were the previous one. Rohit optimized it even further. Like, so yeah, I mean, like this is just with two micro front ends. But I mean, like just imagine if you have like three, four of them, you can save quite a bit of load time. And also, I think with respect to how we showed, right, like with comments, there is also a possibility that all the micro front-end common. So you might have some micro front-end repository which deal with security, and they have some security related common libraries. So I think with the current setup, you should be able to create like, so one can be a common JS, one can be a security common JS. I mean, like the possibility is infinite once you get hold of how to do it with once. I think you can just go wild with that. Yeah, that's it.
There was a question that how are microfrontends different from components? I think Gurpreet already posted a very nice answer in the chat. I will just add to that answer. If someone wants to read that, they can just scroll up in the chat. So one other key aspect where they differ very much, especially in the setup that we have, are microfrontends are full-fledged applications. They are not, they could be just consist of one component, they could consist of multiple components, but the idea is that they are independent applications being developed by separate teams and in their own code bases. And that is a distinction which usually does not happen in components. With components, you usually end up with components that all require each other. This component needs that one needs that one, and you start creating that dependency on different teams. With microfrontends, because each one of them are independent, and again, that key that they are independently deployable. Search in this case should not depend on the release cycle of login or the wait for the login team to finish their work so that you can go online. I think that's a key difference as well.
Yeah, and I think I forgot to show, but even without the container, you should be able to run the search and the login separately. So they are like full applications of their own. They don't really need container. I mean, you can put it in the container. That's the benefit that you're getting out of it. But yeah, I mean, like not really necessary.
Going to the next slide. Okay, uh, sensible defaults. One key aspect here is that you may have to use the same versions for important things like React for all your microfrontends as far as possible. That is because now you are sharing that, and yes, that could be a concern, but I think the benefits outweigh the concerns that you will have to work across teams. Just communicate that these are the versions that we want to use for React and Material UI in this case. Keep an eye out for tree shaking optimizations, like we just said. If you're including entire libraries, that is not going to give you the benefit. You want to be specific about what parts of a library that you are using. For small libraries like, let's say, Lodash and React, which have very small footprint, it doesn't matter. You can go ahead and include them all. But for big ones like Material UI uh, and other design system libraries, if you have like Bootstrap, you want to make sure you only include what is actually being used. Uh, so another thing is keep adding to commons, but don't remove from it. So if you suddenly remove React from one of your common bundles, and then that could break the micro frontends which are still dependent on React being present by that micro frontend. But you can keep adding. It doesn't matter. Whenever those micro frontends do a fresh build, they will now know. Let's say you have already included React and you just added style components to the commons bundle. Whenever search or login build for the next time, they will take the latest manifest file. They will know, okay, style components is now added, and they will stop including that. Until then, they will run normally with style components included in their own bundles. Doesn't really hamper them. So try not to remove dependencies without communicating with everyone. One more thing that could really benefit is don't change it too often. Keep changes to commons very uncommon. So once you go into production, try not to change it at all. At least we have not changed it yet. And that gives us a very big benefit that this is the biggest bundle, if you ever noticed. This is, I think, I don't know where my browser is. Just a second. I'll just go to the previous slide. Yes. Present. Sorry. So if you notice this, this becomes your biggest bundle. These are very small. I mean, these, it doesn't matter, but this is going to be your biggest chunk. And if you don't change this, you can give it a very slow, long time to live in browser caching. You can tell browsers that, okay, you don't need to refresh this for a month, for not a month, that's unrealistic, but for 2 days, for 3 days, when generally for these applications, you would keep the time to live within 24 hours, sometimes within 2 hours. So that gives you a huge benefit that this major chunk is not going to be downloaded for each user again and again. Only these will be refreshed sometimes. So that will load your site even faster. And that was the last point that I already explained. Be very aggressive with caching this common structures bundle. Okay, now uh, let's go back to some code. I already gave a spoiler. This is the second time I gave a spoiler.
Rohit, I think we have less time, so probably we
Okay,
can
yeah,
keep it short.
yeah. So
So
you
this is
don't
like
have,
just a bonus.
yes.
So yeah.
So you saw we went and modified search and logging Webpack bundles. If you go to the React website, they don't actually recommend you touch the Webpack configurations directly because this is very crucial. Any syntax error, any small change in this could break your entire application. So it is recommended that you don't change these files or don't even keep them open. So in a default CR create React app setup, these files are not available. We have them here because we ran npx eject, which throws out the Webpack configuration. So how do you then make sure to do these changes? What we did is we created a custom create React app. Basically, what that means is you take the create React app repo and you fork it. You create a fork on GitHub, and then you make changes to packages, React scripts, config, and Webpack configuration. And you make changes to these files and you publish them as a private NPM package or in your own local NPM repository if you have one. And the next time you need to create a micro frontend, all you have to do, let me create a new terminal. All you have to do is something like this, npx create React app.
Your terminal is not visible, Rohit. If it's just me.
Visible now?
Yeah, now it is. Yes.
Yes. All you have to do is npx create React app test, that is the name of the application. The version of the scripts, we are calling it Geek Night. That's how we published it. And we are giving a template. That's up to you. If you want to modify, let me show the code again. Uh, Create React app actually also contains something called a CRA template. This is basically all your default index.js, app.js. And whatever changes you want to make, you can make to these. If you see the changes that we had made in those applications, we have made here as well. And the next time we need to create a micro frontend, we just run this. And this basically creates a new micro frontend with all our configuration of Webpack hidden, so it cannot be changed, and already ready with the entire DLL plugin and everything set up.
Yes.
All right, I think we are out of time, so I will go back to.
Yes, I think that we just have one slide. I'll quickly cover that 2 minutes, and then we can have 5 minutes for Q&A, hopefully.
Yes, let me.
And for those who wonder, yes, that works. We tried it. We're just not able to see it. I think we'll share the repo links. You can go ahead and just go while on their own.
Yes.
Give it a shot. I think we'll share the links in the end for all these repositories. Right. Oh, okay.
Okay.
I thought there was one slide of, I think, fallbacks. I don't know. Okay. I will anyways go on. Not everything is golden with micro frontends. It does have its own pitfalls. And I think somebody asked a question of communication. How do they communicate with each other? So again, I would say the communication is a bit of complexity that this micro frontend architecture brings in. And there are certain ways, I mean, like that you can communicate. You can communicate via the URL. You can communicate via some local state. I mean, like there are multiple ways. I think we've shared the references. You'll find those ways there. But again, like the key here is if your two micro frontends are talking so much with each other, they are continuously communicating. I think that's an anti-pattern, which you should observe that maybe they should have been just one micro frontend instead of two. So I think one of the drawbacks is that, and I think a couple of others is also on the similar lines in terms of like I forgot. One was yeah, communication is one. Then the common content, yes, pitfalls. I think you already covered it. Then
Yes,
we're good.
yes,
All right.
Okay. So adding to that of how micro frontend would communicate, one common thing that we have seen many projects do successfully is use window events, because they all share the same browser window. You could all subscribe to similar events. One also other thing we have seen is in projects, people using the same Redux store, with all of them using the same Redux store and just registering their own reducers. And that common Redux store becomes a way for different micro frontends to communicate. But like Pallavi already said, if they are communicating too much, you probably had the slicing wrong.
Yeah. Okay, I think time for Q&A.
Yes.
So, okay, what is, okay, micro frontend components we already covered. I think Rohit had another question. I'm also working on Angular 2 plus for a while, and now we talk about lazy loading as we further break down and modularize. Doesn't that cause some sort of an issue with the old code, say in JSP, JSF, not to mention if the legacy app uses GraphQL for various modules and features?
So really, I think what features the older application had is something you can build in your micro frontends as well. For example, if it's GraphQL, you could build GraphQL support in your micro frontends. If it's something like a Gatsby project or a Next.js project, these frameworks will provide you with ways to do GraphQL directly out of the box. Another thing is, how would you use that in an older application? Actually, if you have an older JSP application, Micro Frontend is the better solution, because then you could slowly break down, remove each chunk and create Micro Frontend. And you don't have to worry about creating a new application from scratch right on day one. And it works really well. That is actually how our setup is. We have a JSP application. All we do is include a Micro Frontend, provide a ID, and keep that empty container in place on the page for the Micro Frontend to bootstrap. And it works magically together. We never had any issues.
Okay, how do independent micro frontends? I think we covered this question. How about if we use Webpack module federation plugin in case of micro frontend? I think Rohit, you're the best person to answer.
Yeah. So we were, and I'm really happy that this question came up, because we are actually exploring that right now. We have on Webpack 4 module federation. I think it's much more stable from Webpack 5. And we are also starting to explore if we can move to this. This does look like a really promising way to go forward. But most even Create React app today, they use Webpack 4. I don't think module federation is present in Webpack 4. So as this situation develops, this is JavaScript world, things move really fast. Maybe module federation is going to provide us a better way ahead, but maybe we don't really know.
Yeah. Okay. Rohit, I think you can, on the slide, you can put the last one. If people want to get a link of the repo, they can while we do the Q&A. Yeah. All right. Next question. So how does Micro Frontend communicate? We took that up. Is there a way that Common knows what to include and what to not? I mean, I can give it a shot. So I think we did show that in the commons itself, while you were defining the entry point, you actually tell it that, these are the dependencies that you should include when creating a build folder. So I think that's it. I mean, like you can have, if I just can share, all right, you can share the commons one, just the common webpack.js.
Share as in on the screen?
Repo, yeah. Yes.
Okay. Can you see? I don't remember if my
entire. Yes, I can see the one.
Okay, this is the commons repo.
Yes, like the webpack config. Webpack config. Right? Yeah. So this is the common JS, and I think if we go into the webpack config file for the commons, you will see the entry point. So that's where we tell that the commons that I'm trying to define will have all of these libraries. So I mean, like you can have a bunch of list of them, and you can have commons, you can have, I don't know, other commons for other repos. But yeah, this is where you define it.
But you would define it manually. It's not
okay.
going to
Yes, yes. You will have to include it into your package JSON. You have to put it into this repo and just manually put the entry there. Next question. I think we'll be able to take only one. This will be the last. How does the new Webpack 5 module improve the whole Y front end? I think we covered it sort of. uh, Another one. How about a case when we have one micro front end in React and another one in Angular? I suppose the common chunk will be much smaller but bigger individual chunks.
Yes, I think they answered their one question. That is what would happen if you have
Yeah.
micro frontends that don't share a lot of common code. Then this may not even be a solution for you. Actually, you could just go ahead with having independent bundles and not worry about them at all.
Oh yes, yeah. The last question. I am sorry, it's out of time, but I will take that up. I mean, like there are few micro front-end frameworks available. Why didn't you just use one? Any specific reason? Just trying to understand your approach, thought process to gain insight. We used a single SPA framework for our micro front-ends. I mean, like I can go. So when we started with the whole micro front-end terminology, I don't think there were any frameworks that were available at the moment. And I think these frameworks kicked in about a year down the line when we were working it. So that would be the reason. And personally, I mean, like I've never really dabbed on the framework, but yeah, I mean, like I've also read a bit about it. Rohit, if you have anything to add.
Yes. Also, these frameworks are fairly new even today. One other point was you would, I mean, these frameworks would make sense if you're starting a project from scratch. Uh, that is not always the case. Many times you have existing, like we said, backend based, JSP based applications, which you are just breaking down one piece at a time and turning to micro frontends. And in those cases, those frameworks would not really work very well. We did explore those back in the day, but we realized that the best setup for us was to just do it from scratch. Also, I am not sure all of those setups, those frameworks even help with sharing these dependencies and reducing the bundle size. Uh, uh, Maybe something for us to even explore going ahead. Like we said, even today, I think those better than those frameworks, the module federation is looking like a more promising future solution. At least that's my opinion.
All right, with that, I think we are done. Thank you all for joining. Sorry for the 3-minute overtime. We didn't calculate it through. Yeah.
Yeah, thank you, Pallavi. Thank you, Rohit, for this wonderful session and also the good demo. Hope everyone got to learn something and they can put to use in their daily work. So we'll be uploading this recording in YouTube channel. So meanwhile, let me post the link of the YouTube channel. So you can also explore the other topics that are present in this YouTube channel playlist.
For the feedback link, Sridhar, I don't know how do we share that?
Can you put in chat?
I can't hear you, sorry. Oh, I think my connection was unstable. I was just asking where do we record the feedback? Do we share the link later?
Yeah, sure. We can also put it in the comment of the meetup link.
Nice.
That can also give the
Let's do that.
notification.
Yes.
Great.
Okay.
Thank
Stop.
you everyone for joining.